warm welcome to this virtual training series on building applications and solutions with Microsoft 365. I'm Monica from TechnoFocus, and I'll be serving as your moderator today. We're glad to have Becky Bertram with us, who will be presenting this series. She is a Microsoft Certified Trainer and Microsoft MVP. She is currently based in the U.S. Before we get started, let's have our housekeeping announcements for the day. If you happen to face any audio or video issues during the webcast or have any technical questions, please post them in the Q&A panel and our team is here to help you. Now I'd like to turn today's event over to our presenter. Becky, you have the floor now.
Hi there, and thanks for joining me for Building Applications and Solutions with Microsoft 365. This is day one of our online training. So let's talk about how this course is going to be structured. Today, on day one, I'm going to be talking about implementing Microsoft Identity, and this includes authentication, authorization, and consuming APIs using the Azure App Model. On day two, we're going to talk about building apps with the Microsoft Graph. We're going to talk about how you can access user data from the graph, managing the lifecycle, and optimizing data queries. On day three, we're going to talk about extending and customizing SharePoint, including using the SharePoint framework, SPFX extensions, and understanding how we can package and deploy our SPFX solutions. On day four, we're going to talk about extending teams. We're going to understand the components of a team app, understanding webhooks, tabs, messaging extensions, and conversation bots. And finally, on day five, we're going to talk about the fundamental components and types of Office add-ins. We're going to talk about using the Office.js APIs and understanding the customizations of add-ins. I hope that you can join me every day this week for these topics. The first thing we're going to talk about is implementing Microsoft Identity. During this part of the presentation, I'm going to give you an overview of the Microsoft Identity. We're going to talk about the different account types in the Microsoft Identity platform. We're going to talk about topology options and the permissions and consent framework in Microsoft Identity. So first, let's talk about what is Microsoft Identity here. The idea is the fact that you have many different kinds of applications. If we look on the left side of the screen, we see cloud apps, on-premise apps, but then we also have people on the right side. These could be partners, customers, employees, and then finally you have devices. Who are the people that are accessing your applications? What are they accessing it with? Is it a computer, a watch? Is it a printer? We can see all the different kind of devices that people can access with. As the concept of application security has matured over time, we realize that there are really a whole bunch of variables involved in terms of who can access what information. For instance, an employee may be able to access information if they're on their company network, but maybe they shouldn't access it if they are not on the network. Or maybe they can access it on their computer, but we don't want them to access it on their smart device. So this is where this whole concept of security becomes really complex. And so what Microsoft Security does is it helps you to set up various policies to manage these different scenarios in a very easy and unified way. So when we talk about the concept of security, really security starts with users. There are people and they need to have security assigned to them. Next, we have the resources that are being secured. So if I log in, I'm Becky, and I log in and I would like to access the HR website in SharePoint, then I have a policy applied that says Becky is going to be able to have read-write access to the HR site in SharePoint. So the idea is we have a person or a group of people that are being provided a specific kind of access to the object which is being secured. When we're talking about something like the graph, it may be users that need access to information in an Outlook mailbox or a OneDrive folder. The key with this is, while it can seem very straightforward to set up permissions at that very local level, on a more macro sense, you want to be able to set up policies that work with a large number of users And even though you may have various security policies in place, you don't want to actually have to set up a separate policy for every single user, right? You want to be able to have overarching policies that work for a large number of resources. You want to be able to include the most number of users in those policies so that you have the least level of maintenance. So again, this identity platform is going to help you set up these large-scale approaches to managing identity and access within your applications. The first of these options is external collaboration using B2B, or business to business. In this case, we have Contoso and Fabricom, which are two different tenants within Azure Active Directory. In this case, user A wants to be able to share a document with user B. Now, what user A can do is share the document, and user B can authenticate with the Contoso domain. When this happens, user B can now access the document stored in the Contoso environment, but user B still actually exists within the Azure AD tenant within its own organization. It's just authenticating across that boundary. The next option we have here is Azure Active Directory B2C. This is a scenario that extends the OAuth concept so that you can now authenticate any number of ways with Azure Active Directory. For instance, people can authenticate using their organizational accounts, but you can also allow people to authenticate using social accounts such as Facebook, Twitter, LinkedIn, Microsoft, Google, etc. In addition, really any provider that uses SAML 2.0 can also connect using this B2C connector. So this is a way where you can allow people to authenticate using personal accounts or really custom authenticators and can still connect to Azure Active Directory. The next thing I want to point out is how the Microsoft Graph is what connects you to everything within Microsoft 365. It used to be back in the day that developers needed to know APIs for all the different workloads. So if you wanted to connect to Exchange, you needed to know the Exchange API. If you wanted to connect to SharePoint, you needed to know the SharePoint API. It became very difficult because people needed to have such a wide range of information. It became difficult for developers because really you had to, for one, know all these different APIs. But more than that, insights between the two really were not discoverable. For instance, there are many times where these different workloads are going to be working together in unison. We already know about like the unified Office 365 group. So this Office 365 group concept is what ties together users so that they can use Teams and Outlook and distribution lists and SharePoint OneNote notebooks and everything together. Once you connect to the Microsoft Graph, you not only have a unified API to connect to all the different workloads within Microsoft 365, but you also now have access to things like the insights and everything else that's available in terms of the analytics that are involved with the platform as well. And that's what we can see at the bottom. Microsoft Graph really is just an API. So it means that you can connect to the Microsoft Graph using web apps, using native apps, device apps, bots, background processes, etc. And we're going to be talking during the session about how these different sort of applications can authenticate to be able to access the Microsoft Graph and use the Microsoft Graph then to get information that's stored within Microsoft 365. So far, we've looked at what Microsoft Identity is from a high level. As a developer, when you build an application, you ultimately request tokens from Microsoft Identity to identify a user and authorize them to use an application with specific permissions. Let's look at the different tokens that you can use. The first type of token is an ID token that is made available via Microsoft's identity support of the OpenID Connect protocol. Now, OpenID is really an extension of the OAuth 2.0 authorization protocol to use as an authentication. Now, OpenID Connect extends the OAuth 2.0 authorization protocol to use it as an authentication protocol. Again, keep note of that, authorization versus authentication there. And OpenID Connect enables you to implement single sign-on using OAuth in your applications, and it introduces the concept of an ID token. An ID token is a security token that allows the client to verify the identity of the user. The ID token also gets basic profile information about the user. Because the OpenID Connect extends OAuth 2.0, apps can securely acquire access tokens, which can be used to access resources that are secured by an authentication server. The claims included with an ID token can be used for the user experience within your application, as keys in a database, and for providing access to the client application. ID tokens for Microsoft Identity are JSON Web Tokens, or JWT. These ID tokens consist of a header, a payload, and a signature. The header and the signature are used to verify the authenticity of the token, while the payload contains the information about the user requested by your client. So on this slide, you can see some of the ID token claims. Now, ID tokens contain claims in the payload. In this chart, we can see the various kind of claims that are available within the ID tokens. I'm not going to go through this whole list right now, but just make a note of the various kind of noteworthy claims that you can go back and study later. When talking about obtaining ID tokens, developers should use a well-maintained OpenID Connect library like MSAL, which is the Microsoft Authentication Library. Many web apps need not only to sign the user in, but they also need to access a web service on behalf of the user by using OAuth. In terms of obtaining ID tokens, developers can use the Microsoft Authentication Library, abbreviated as MSAL, to obtain the ID tokens. For example, if we look at the screen here, we can see that we're creating a new MSAL user agent application, passing in the config file, and then using the login pop-up function. Many web apps need not only to sign the user in, but also to access a web service on behalf of the user by using OAuth. This scenario combines OpenID Connect for user authentication while simultaneously getting an authorization code that you can use to get access tokens if you're using the OAuth authorization code flow. It's important for developers whenever possible to use a well-maintained OpenID Connect library. While Microsoft Identity is built on open standards like OAuth 2 and OpenID Connect, fully implementing these protocols is time-consuming and complicated. It's also required that any implementation of these standards to be kept up to date with the latest recommendations to ensure the implementation is as secure as possible. When your web app needs to authenticate the user, it can direct the user to the Microsoft Identity Platform /authorize endpoint using an OpenID Connect library. At this point, the user is prompted to enter their credentials, enter a multi-factor, use a FIDO2 compliant device, or perhaps use a passwordless experience, such as Microsoft Authenticator or Windows Hello, to complete the authentication. All of these options are handled by the platform without any additional code from the developers. The Microsoft Identity Platform endpoint verifies that the user has consented to the permissions indicated in the scope parameter. If the user hasn't consented to any of these permissions, the Microsoft Identity Platform prompts the user to consent to the required permissions. After the user authenticates and grants a consent, the Microsoft Identity Platform endpoint returns a response to your app at the indicated redirect URI. In terms of obtaining ID tokens, it's important to use a well-maintained OpenID Connect library like MSAL, which stands for the Microsoft Authentication Library, to get your tokens. The important thing about this is the fact that standards can change on a regular basis, and you want to make sure that you're using up-to-date code. And so by using the MSAL library, you know that Microsoft has ensured that there is a framework out there that's going to use all the latest protocols. If you use the MSAL library, what it does is it provides sort of a bundling of these classes that allow you to pass the ID tokens around without you having to do the work of making sure that when they expire, you make sure that the expiration is renewed and all this sort of stuff. If we look at here, what happens is using the MSAL object here in JavaScript, we essentially can call then this login pop-up. And what we do in this scenario is we not only are saying provide the user authentication pop-up, which is going to then allow them to authenticate with Azure AD. We're also going to pass in the scope that we're asking for permission for. So essentially we're passing that ID and saying, here's the ID token that I'm passing to Azure AD, and I'm specifically asking permission for a particular scope. Now, a lot of times applications not only have to assign a user in, but they need to access another web service behind the scenes. For instance, if I'm going to log in and access a web application, and then that web application itself is now going to call and access the Microsoft Graph, we have sort of a two-step authentication going on. So access tokens, different than ID tokens, are going to enable clients to securely call the APIs that are protected by Azure AD. Now, there are a lot of scenarios where once a user is authenticated with Azure AD, the application that they're calling itself may need to call another API behind the scenes. So for instance, the user is accessing a web application that I've built, but that web application now wants to call the Microsoft Graph on the back end. What we can do in this scenario is we may not necessarily want to pass user credentials to that other API. We may not consider that very secure. So what we can do is we can pass in the user ID token, and then Azure AD is going to basically pass us back an access token, and then that access token is passed on to the other web API. So access tokens enable clients to securely call APIs that are protected by Azure AD. And this way, applications are never going to look at the access token. It's just a way that they can say, all right, Azure AD, I take your word for it, that they have authenticated and this is who they are. And so that way, those APIs that you're calling don't really need to have any specific information by the user. They're just basically saying, Azure, I trust you that everything's okay. Now, when you're obtaining the access tokens, it's always important to try and do this silently at first because you don't want users to keep getting the pop-up windows. So what you can do is you can call the function acquire token silent. And when you pass that in, again, you're going to pass in the user's account and the scopes that you're requesting permission for. And scope is a way of providing different options for which level of security you want to have access to in that backend API. Once you get a result back, then you can acquire that access token back from Azure AD, and that's what you're going to pass along with your next request. And that's what your other code is going to use. You're just going to basically saying, hey, I've got the access request token and everything's good. This simple pattern enables single sign-on as well as handling the IT policy because users are still authenticating with Azure AD, but you don't actually have to keep passing credentials on to those child APIs. You basically delegate them and say you have permission to operate. It's important to note that there is a difference between user and application access tokens. We've already talked about how a user can authenticate and pass that access token on as the user, but it's also possible for service applications, background processes to run, and these other kind of applications are going to really run under a service account. They're not really like a user. It's really the application itself that is going to be requesting permissions to run. So these app-only tokens indicate the request is coming from an application and there's not a user per se that's authenticating. So as you decide how to build your application and how to secure it with Azure AD, you're going to have a number of questions that you're going to run across, and we're going to walk through some of these questions here. The first thing I want to point out here is that we use the word application a lot as we're talking about this, right? So you could have your application, your custom application that you're building. And typically when we talk about an application, we may be talking about the actual custom code we're building, right? Well, when we're talking about an app here, we're talking about simply a registration for the app. This is an app registration. So when we are talking about the Azure app, we're not talking about the code base. We really are just talking about the authentication mechanism for the app. Now, when you register an app, you can have a name, a logo, a publisher, and then you can also have information in there about things like what are the terms of service, what is the URL for the company that's publishing it, what's the privacy policy, etc. This is all stored within a manifest file, and we'll talk about this later during the course. Now, you can only have one app registration for app, and this is the application object. So you can't register one app multiple times. You are just going to have one application, and you can apply multiple policies to the app, but it really doesn't make sense to have multiple app registrations for the same app. Now, when you're deciding how you're going to register the app, it's important to talk about the scenarios which we talked a little bit before in terms of how people are going to be getting to it. Are they going to be just users within your organization? Is this a private application that you've developed for your company or your organization? Or is this something that you are a software vendor, an ISV, and you want to publish this out so that multiple organizations can have access to it? Or is this something that is going to be still sort of private, but is going to be accessed by multiple Azure AD tenants, as we talked about in a previous slide? So in this first scenario here, we're basically writing what we would call line of business application. In this case, the app is registered for a specific Azure AD directory. This is the most simple scenario. It's a single tenant. You are going to go to the Azure AD app registrations and register your app. Now you can do it with the Azure portal. You can register it using PowerShell, using scripting. There are various ways to do that registration, but the key is it's happening in one tenant. And in this case, the admins can decide who can register the apps in their tenant. No one outside of your organization is going to be able to access this app. This really is just for people within your tenant. Now, in the next scenario, this is a multi-organization app. In this case, you can allow either anyone in Azure Active Directory, or you can allow people in Azure Active Directory and using these Microsoft personal accounts. So if you log in with Outlook.com or Xbox or a Skype email address, these would be those Microsoft accounts. And in this scenario, we have this multi-tenant setup. So what happens is you still are going to register the app in the home directory, and that service principal gets registered there. But when someone installs the app within their tenant, it's basically going to create a separate service principal that's sort of a copy of that original service principal. So that new service principal does live within their Azure Active Directory tenant, but it's sort of using the, it's sort of a photocopy of that same service principal that was created originally as a kind of template. Now, building apps for multi-tenants can be difficult. The first thing to note is that you may be requiring authentication, but it may be that if this app is installed in a different tenant, that they may have different policies in place. They may require MFA and maybe you don't. So if you're asking them just to log in, but you're not accommodating things such as these additional policies, it may be that your app isn't going to work so well in their environment. Additionally, you may assume that users consent to an app, but maybe in their environment only admins can. Additionally, you may think that, hey, if I'm writing this for my company, I don't see why they'd have a problem with me writing to the Outlook calendars. However, it may be that in other organizations, they say, I don't think so. I don't want to use your app. That's too much. So you always want to make sure that your app is really using the least amount of privileges. Otherwise, people may nix it. When you're building apps, you may provide different scopes. There's the scope that says admins need to consent to this or users consent to that. Anytime you have that admin consent, you're necessarily going to have to get their IT department involved. And if you want to have the most user adoption of your app, it's probably not a good idea to force that, because that's going to become a kind of bottleneck there. Finally, you want to make sure that you provide the names and descriptions for the permissions exposed by the app. I already mentioned those scopes. Within that scope, you can create custom scopes based on whatever your app does. So you want to make sure that you're being truthful and honest about what is it scope is doing. If they're saying, I need your permission to do this, this, and that, the users or whoever's consenting to it needs to make sure that they know exactly what it is that they're consenting to. As I already mentioned, it can be confusing when we use that word application, because application can be it's sort of a generic term. But when we talk about an Azure AD, when you register an application, you get two things. You get an application object, and this is what the developer knows about the application, such as certificates or secrets, how users are going to authenticate with the app, the permissions, the scopes that are going to be exposed by the app or that the app is going to use, app roles. Whereas the service principal object, it determines how that application operates within the tenant. And it can limit the application to specific users and groups. It's used to review app permissions and grant admin consent. It can be used to assign users and groups to roles. It can configure the app for automatic provisioning, and it be created when an application is granted permissions to a resource and a tenant. So essentially what happens is that application object, that's what's really global and across all tenants. So that's the information about your app itself. How are people going to authenticate it to it? What's the company that's publishing it? The service principal object is essentially, that's what gets copied to each local tenant. So within your original tenant, you do have a local service principal object, but then you're going to have another service principal object that's created and consented to within another tenant if you have a multi-tenant scenario. If you have a single tenant scenario where you're only installing this once, the service principal is created and consented during the app registration. Whereas if you have that multi-tenant scenario, each tenant has to consent to the application's use. Let me walk through the interface for registering applications, show you the connection between an app registration and service principals, and give you a demo of that consent process. In this demo, I just want to walk you through the Azure registration portal for registering apps. I have navigated to the Microsoft Azure portal homepage, and I'm going to click on Azure Active Directory. From here, I'm going to click on App Registrations on the left nav here to be able to get to the app registration page. And this is really where we're going to be living for most of this module. Notice here that if I have an app that I've already registered, it has a name and an application ID. Sometimes you're going to see this called an application ID, and sometimes you're going to see it called a client ID. You're also going to see if the certificates and secrets are up to date. To create a new registration, I'm going to click on the New Registration button, and I'm going to give my app just a test name for now. Now this is where I have three options. I can register the app for a single tenant, for multi-tenant, or for multi-tenant with personal accounts. I'm going to select the one that allows me to create it with personal Microsoft accounts. As you can see here, I also can have that redirect URI. This is after authentication has happened. This is where that token gets returned to. I'm going to fill that in later. It's now creating my test app registration. If you look here, I can see the application or client ID here at the top. I can also see the directory ID, also referred sometimes as the tenant ID. Finally, I can see the object ID specifically for this app. If you look up here at supported account types, it's all Microsoft account users. And this is where I can specify a redirect URI or the application ID URI. If I click on the left side here and I click on branding, this is where I can choose to upload a logo. I can have a homepage URL, I can have the terms of service privacy statement URL, and a public domain. Right now I'm in my test domain right now, so it's not a public domain. This is especially important if you are going to be publishing your app out to a wider audience. This is where they can get information about who you are and who your company is. When we click on authentication, this is where we can see various settings here. We've already established that this is going to be available for accounts in any organizational directory. In terms of the platform up here, because this is the registration seems to indicate that this is sort of a consumer-facing app, you can specify the platform that you're going to be publishing your app to. You can specify if it's iOS, Mac, Android, desktop, or if this is just a web application, such as a single page app or a web app. We'll select web app. If this is the case, it's going to want that redirect URL and the logout URL. If we need to upload a certificate or have a client secret here, this is where we can enter it. And we'll talk about it later in this presentation. The client secret is an easier way to secure your item. It's really just a long password, whereas the certificate is more secure and is the kind of thing you would want to use in a production environment. API permissions. This is where you can set the kind of permissions that people are going to be getting access to. And again, we'll talk about this more later in the presentation, but right now you can see that this has a scope name, the type is delegated, and a description here. For expose an API, this is where you can actually say that my app is going to actually expose another web API that's available. We can see the owners for the app here. We can see the role administrators. And finally, if you want to edit detailed information about this, you can do it in the manifest. The manifest is structured as a JSON document. There are some things you'll see that are only editable in the JSON. For example, if you set up your app originally to be a single tenant app, but you decide later on you want to add the ability to authenticate with Microsoft accounts, you can do so by editing the manifest here. You can see here the kind of flows that are indicated if you want to enable implicit flow, and we'll talk about these in the slides to come, the different available flows that are available to you. This is where you can specify things like your terms of service, support, privacy, public URL, etc. So a lot of the information that you can edit here in the user interface, all it's doing is providing a way to edit that manifest here. Next, let's talk about identity topology options. We're going to be talking about several kinds of accounts that people can authenticate with. The first kind of account is a Microsoft account. Now these are accounts that people use when they're logging on to consumer applications. When we talk about Outlook, we're talking about Outlook.com, not Outlook that's part of Office 365, but if someone just has a consumer email address that's at Outlook.com, or if it's legacy, it may be MSN.com, Hotmail.com, etc. People can also have consumer accounts to log into OneDrive, Xbox Live, in the past it's Skype accounts, that kind of thing. In the past, when we built web-based applications, it was very frequent to have something called forms-based authentication, where people would supply their own username and password to your application, and then you were responsible for maintaining that password. When we use this approach, you no longer have to be in charge of that password, and from a security standpoint, you don't have to maintain that and make sure that all their passwords are safe in your system. You can just use this for single sign-on capabilities for them to authenticate using their accounts, and all you're doing is getting this entrusted token that we talked about, but you aren't actually responsible for keeping track of their password. As it says in this last bullet point, it's a standards-based approach for adding single sign-on capabilities for custom apps. Next, we'll talk about authenticating with enterprises. The important thing to note here is that this is the topic we've been going over and over again here, is that Azure Active Directory not only allows you to manage identities, so users and their passwords, but also application principals that we've been talking about, the way to register applications. So what this means is not only do you have accounts access to the users, and these are usually the accounts that people have logged on to their computers within your organization, so you have access to their user data and information about them that is stored in Azure Active Directory, which may or may not have originated with on-premises Active Directory, but it does again provide this ability to authenticate not just users but these apps leveraging the OAuth 2.0 protocols. We already talked a little bit about Azure AD B2B, and what this does is it allows you to provide guest access to content that resides within your tenant. It uses single sign-on capability, which means that your guest users are still going to be logging in and authenticating with credentials from their environment, but you are basically granting them permissions in your tenant as a guest users. Now, users can be sent invitations in bulk, or you can create self-sign-up portals, as is mentioned here. So if we look at this scenario, a user from Fabricom needs to access content within the Contoso organization. Because the content is protected by Azure AD, the user will be redirected to Contoso to sign in for authentication and authorization. Now, Contoso's Azure AD recognizes the user as a guest from Fabricom, and that Fabricom is configured with B2B Contoso, so Azure will redirect the user to Fabricom. After the user signs in with Fabricom, they'll be redirected back to Contoso's Azure AD that validates the Fabricom generated token and creates a new token for the user to access the content. Because the new token is created by Contoso's Azure AD directory, it can be used to access the content because it only trusts the Contoso Azure AD directory. Azure AD Business to Business provides administrators and developers in many ways to grant guest users from another organization access to your own content. An admin can create a new guest user in an Azure AD portal, similar to how you'd add a new user, and they can be sent an email invitation or added in bulk using PowerShell. Administrators can also delegate group owners, and application owners manage their own guests so that they can add guests directly to any application that they want to share. Once a user has been added to your directory, you can use Azure AD's conditional access policies, such as multi-factor authentication, to further protect your content at the tenant level, application level, or for specific guest users. Azure Active Directory B2C is a Customer Identity Access Management Solution, or CIAM solution. It can manage a really large throughput of users and authentications per day. It allows users to authenticate using social accounts like their Facebook account, Gmail, Twitter, or they can authenticate with their Azure AD organizational accounts as well if they want. Azure B2C also handles monitoring and automatically addresses threats such as denial of service, password spray, brute force, etc. And it uses standards-based authentication protocols of OpenID Connect and OAuth 2.0. Within Azure AD B2C, users will authenticate with their preferred identity provider that has been configured by your IT administrator. The user sign in a customized sign-in page that is hosted by Azure AD B2C. Because this is a custom page, you can actually give it custom branding because you're the one who's building it. You're doing the authentication behind the scenes, but you're the one who can manage it if it's something that you decide to build into your application. So it is considered white label, so you can, again, provide your own branding to it. After the users sign in, you can implement something called progressive polling. And this allows your customers to quickly complete their first transaction by only signing up with the minimum amount of information. So at the beginning, you may just need them to enter their email and phone number. And then down the road, you can ask them for more information. So if we look at the screenshots here, we can see that after they first signed up, then they can go in and edit their profile, and they can add their birthday, and then later they can add preferences with additional information. So that means that over time, you're actually adding more and more information to their account within Azure Active Directory. However, it's not required from the get-go to create that initial user account. So Azure B2B is for businesses that want to securely share files and resources with external users. And an Azure admin sets up B2B in the Azure portal, and Azure AD takes care of the federation between your business and your external partner. And users sign in to the shared resource using a simple invitation or their organizational account there. Azure AD B2C is primarily for business and developers that create customer-facing apps. With B2C, developers can use Azure AD as the full-featured identity system for their application, letting customers sign in with an identity that they have already established, like with Facebook or Gmail. Next, let's talk about the application types in Microsoft Identity. The first one that we're going to talk about are called single-page applications. A lot of modern applications are built using a client-side approach, such as using JavaScript or a framework like Angular or React. And in these cases, these applications run entirely in a browser, and there's really almost no server-side components. So unlike approaches such as active server pages, ASP.NET, or other approaches that are going to be sending requests to the server and getting a response back, these approaches are written almost completely using JavaScript. And being a single-page application, it means that JavaScript is going to be fetching and returning different components to the browser, but the user is never actually navigating away. That URL at the top that they're at is never actually changing. It's staying the same because the whole application was written in the context of a single web page. This kind of application can provide some unique challenges. For instance, having users redirect away to authenticate and come back can kind of mess up the state where they're at in that application. And a lot of browsers prevent the ability to have scripting that goes across URLs. For security purposes, they don't want someone writing malicious script where it reaches outside of the URL from which that script executes in. So for this reason, you can't really leave the environment or leave that parent URL or the place where you're at. Because of these limitations, the Microsoft Identity Platform allows single-page applications to sign in users and get tokens to access the back-end services or web APIs using the OAuth 2.0 implicit flow. The implicit flow allows the application to get ID tokens to represent the authenticated user and also access tokens needed to call protected APIs. In order for single-page applications to use Microsoft Identity to enable users to authenticate and obtain access tokens, you have to register a new app with Azure AD. And you can do this using the Azure AD Admin Center. By default, Azure AD apps don't support the OAuth 2.0 implicit flow grant. After registering the Azure AD app, there are a few things you need to do. First, you need to ensure that the redirect URI of the app points to the URI of the single-page application. The URL has to match the redirect URL provided by the single-page application when the authentication process is initiated. Next, you have to ensure that the implicit flow is enabled by selecting the ID tokens option on the app's authentication settings. If the app is also going to request an access token to use in authentication requests to other Microsoft Identity protected endpoints, you must also select the access token options. That would be a case if you are going to access something like the Microsoft Graph, or you're going to access another API that maybe is one of your own custom APIs. So in this case, not only is the user having to authenticate their identity, but they also now have to have permission to access another API that's being called on the back end. The easiest way to use Microsoft Identity for authentication and to obtain access tokens to authorize requests to secured endpoints in a single-page application is to use the msal.js or the Microsoft Authentication Library for JavaScript, which we've already looked at. After you add a script reference to the page so that you can use your script here, you're going to use the following code. If we look here, we're going to pass in this auth object. And in it, you're going to pass in a client ID property. Now, this is going to be the ID of the registered app that you created in Azure. If we look at authority, it's going to actually use login.microsoftonline.com. And then after that, you're going to put in a directory ID. Typically, this is the GUID of your tenant, or it could be a domain name such as contoso.onmicrosoft.com. It would be that official tenant URL, or URI, I should say. And then you can have a redirect URI. Now that you've configured the application, the next step is to get the user signed in. You're going to do this by calling the login pop-up method and passing the object with the wanted permissions defined. So permissions really in this case, as you can see at the top, are defined as these scopes. You're saying I want the users to be able to have access to particular application scopes, and those scopes really map to permissions. The code's going to open a pop-up that loads the Azure AD sign-in experience. And if the user has not granted consent yet, they will be presented with this screen where I can say, hey, this app wants to have access to these various things, and you can accept it. After you complete the sign-in experience, it'll close the pop-up, and then whatever your success function is will fire on the back end of this, which we can see in here as that login response. And in this case, we're going to pass that ID token back to the application after that response has been received. Now, after the user has signed in, the next step is to maintain an access token to use in the authorization header of the request. So we've already got that authentication, and now it's time to send the authorization. And there are two methods on the msal.js API that you can use for this task. The first one is acquire token silent. Now, if the user has already signed in, the method will return a response that includes the access token. Now, if the acquired token silent fails, or you need to have the user sign in an interactive way, you can use this method. And it will combine the request to sign in and it will obtain an access token all in one step. So typically what you're going to do is you're first going to execute that acquired token silent function. And only if this one fails in that catch can you go and try it again, and this time using the pop-up. But this way you're interrupting the user as few times as possible with that pop-up experience if they had already authenticated previously, and they can authenticate again without having to have the intrusion of a pop-up. Once your single page application has an access token, you can use it to call a secured endpoint, such as Microsoft Graph. If we look at this example here, we're using an XML HTTP request to pass in a call to the Microsoft Graph, which we're going to talk about in our session tomorrow, I believe. But when we do that, we're actually passing in that access token as a header. We're doing this by calling the set request header, we're passing in authorization, and then there plus the access token. When we do that, after that, we can make our HTTP request. And again, we'll talk about get, post, all that kind of stuff later. But it's important to note that this is an XML HTTP request. It's happening and it's passing in that token in the header. Now, this is a really complex chart here, but this is basically mapping out the way the SPAs, or single page applications, authenticate and obtain that access token. And it's supported by the Microsoft Identity Platform. The important thing to remember is that the OAuth 2.0 assistant grant flow is a popular way to authenticate using single page applications. If we can sum it up here, essentially you're going to call that authorize namespace. When the user logs in, they're going to enter their credentials. It's going to return a token. That token is going to be then passed with the authorization header to your API. It's going to validate the token, return the data to the single page application. And that's how that authentication and authorization happens. And then after that, if the token expires, you're going to use that silent login to get another token and only provide that pop-up when necessary. The next scenario we're going to look at are web apps that sign in users and call APIs. Now, this is more traditional web applications that do use a server-side call. In this case, the web application is going to direct the user to sign in to Microsoft Identity using a full-on redirect. Microsoft Identity then returns a sign-in response through the user's browser, which contains claims about the user and an identity token. As a second phase, you can also enable your application to call web APIs on behalf of the signed-in user. Now, the OAuth 2.0 authorization code grant flow is a common one when websites or custom apps want to leverage Azure AD as a federated application provider. When the app needs to sign a user in or needs to access needs an access token to act on their behalf, it redirects the users over to the Azure's AD authorization endpoint to authenticate. The user signs in using their email and password, and in turn, Azure AD is going to redirect the user back to a specific URL in the app. And when Azure AD redirects the user back to the web app, it's going to include an authorization code. That code is an encoded string that only Azure AD can read. What's going to happen at this point is the web app is going to take this code, which is only valid for a short time, and it's going to include it in a request to the Azure AD token endpoint. In addition to the authorization code, the request to the token endpoint includes a grant type parameter that tells the endpoint it's exchanging the authorization code to obtain the access token on your behalf. So this is sort of a two-step process here. It's first getting that authentication code, and then it's going to exchange it for an authorization code. The reason you would do this is that the web app never has to see the username and password. All it does is get permission to say, okay, it's been authenticated, we're all good, they have the right claims, we're good to go. That way, you never have to worry about your web app, again, even seeing or being responsible for that username and password. Now, we already talked a little bit about the Azure AD app registration when we talked about that implicit flow. But in this case, we're talking about that code authorization flow. And in this case, you need to make sure that the redirect URI of the app points to the callback URI of the web app. So these have to work together because when that redirect happens, it's going to send the token back to your app, and that has to match that login ID of your app. The authorization code will be sent to the endpoint, which means you need to configure any authentication libraries or middleware to listen to this endpoint to receive the code. So again, your app is going to connect to Azure AD, and that Azure AD is going to send it back to your app. So you need to make sure these line up. You probably want to set up a sign out URL as well so that you can clear out any cached tokens or data that needs to be cleared out. Now, the web app will also need a client secret to sign in with Azure AD to exchange the authorization code for an access token. It's important to know that it is possible to use certificates instead of a client ID. And client ID is good just for simplicity and definitely for dev environments. But if you want to have the highest level of security, you're going to want to install a certificate and use the certificate with the OAuth 2 authorization code grant flow. Now, there are three things you're going to need from the Azure AD app registration, which you'll use within your web app. Number one is the ID of your Azure AD directory, which is otherwise known as the tenant ID. You will need the client ID, which is a unique auto-generated ID of the app. In the other slide, we called it the app ID when we were looking at the MSAL code there. And then finally, you'll need that client secret, and that's the secret that you created during the app registration. If you're using ASP.NET Core, you can use the startup CS file, and specifically the configure services method, to configure any middleware and libraries to handle the authentication to start listening. So at this point, what you're going to do is you're going to set the authority for Azure AD to be the OAuth 2.0 Azure AD endpoint. You're going to request both an authorization code and ID token when the user signs in. You're going to associate the user's name property in ASP.NET to the preferred username claim returned to the ID token. Returned in the ID token, and you want to create a callback when the authorization code is received to add all claims from the ID token to the current signed in user's claim. So these are all things that you can do in that configure services method. The sign-in process is handled by redirecting the user to the Azure AD sign-in page, like we've seen a lot of times already here. This is set by default for you when you create a new ASP.NET Core web app. The sign-in process uses the value from the app settings.json file and the configuration defined in the previous setup to create the Azure AD URL to send the user to. The URL specifies things like the Azure ID, the tenant ID, and the scopes required by the web application. Now, when a user signs into Azure AD and is redirected back to the web application, the web app can use the MSAL.NET library to obtain an access token. Up until now, we've talked about MSAL.js, and in this case, we're talking about this compiled library that can handle similar functions. The account is retrieved from the currently signed in user, and then the token can then be used to call a secured endpoint. If we notice here, we've got acquire token silent. This is the similar method that we saw as a function MSAL.js. The last part of the process is to use that access code and request to a secured endpoint. So now that we've gotten that code, we can now pass it on for the actual work of the application. Now, one way to do this is to create an instance of the Microsoft Graph client and add it as a singleton to the ASP.NET Core's dependency injection system. This would be if you were calling Microsoft Graph, just as an example of the kind of thing you can call in the back end as an API. The instance of the service can then be used from a controller within the web application. The next scenario I'd like to talk about is when you're trying to create an authentication and authorization method for daemon and non-interactive apps. These are apps that need to operate within the context of an application, and there's really like no current user that's in the context. So these might be services that run on a computer, console apps, or simply web applications that are going to run sort of in a service context without accessing information as a particular user. Typically, when we're building applications, we are having users authenticate. So the authentication is happening as a user account in the context of a particular application. So we really call this the user plus app permission model, because you're taking into account the particular user who's logging in. In this case, we're really using the app permission model. We're taking that user part out of the equation. For these kind of apps, we're requiring application permissions, not delegated permissions. Now, because we're running in the context of an application and not a user, these kind of applications must have their permissions approved by an administrator. Applications that require a token for their own identities are confidential client applications. These apps, given that they access resources independently of a user, need to prove their identity. They're also sensitive apps, which they need to be approved by the Azure Active Directory tenant admins. Additionally, they need to have a registered secret, which is an application password or a certificate with Azure AD. This secret is passed in during the call to Azure AD to get the token. Now, if we look at this app registration, unlike the other registrations, there's no redirect because, again, a user isn't walking through this process. It's all happening automatically. But you do need to make sure that you add that client secret. But just like you're not adding in that redirect URI or sign out URI, you also don't need to enable the ID token or access tokens for the implicit grant flow because, again, authorization is not happening on a user basis. Now, daemon applications can only request application permissions to APIs, not delegated permissions. Application permissions are defined on the API permission page for the application registration. Daemon applications are required to have a tenant admin pre-consent to the application calling the web API. This consent is provided in the same API permission page. Let's look at the MSAL.NET configuration here. It's similar to a web app that implements the auth code flow, but in this case, you're going to be passing in that with client secret or with certificate when you're passing in the confidential client application builder object here. And now, in terms of acquiring an access token, as we've already mentioned, there's no sign-in that's required, and that's because the admin has already provided consent. Also, unlike other OAuth 2.0 flows, there isn't a list of required permissions or scopes that have to be included to generate the access token. Instead, there's going to be a single scope, which is default on the end of the app ID for the daemon. So if you look in here, it would be the app ID for your application /.default. And these are all statically defined and pre-consented scopes. Like I say, the admins are already going to consent to it that will be returned in that token response. Finally, you can use the configured confidential client to call a secured endpoint, such as Microsoft Graph. When you're using the Microsoft Graph.NET SDK, first create an instance of the MSAL authentication provider. Next, you can use that authentication provider in creating a new instance of the Graph Service Client object from the Microsoft Graph SDK. And then finally, you're going to use the Graph Service Client to submit a request to the Microsoft Graph. So if we look at this authorization flow, we can see here that unlike the scenario covered in the previous section, this app doesn't need to sign in to obtain an authorization code. During the Azure AD application registration process, you create an SSL certificate public-private key pair. The public certificate is registered with your Azure AD app. And with the service or daemon app, the private certificate is used to sign a JWT that is sent to the token endpoint. Administrators can use a client secret instead of a certificate, but is not recommended for production. In this demo, I'm going to walk through some of the ways you can register your apps to facilitate the different flows. And I'm also going to show you some of the quick starts that are available to get you going if you're building some of these projects. I'm back here at my test application registration here. If you click on Quick Start, you'll see that there are a number of Quick Start guides available to get you going. So for example, if I wanted to start up with a single page application just using JavaScript, I can click on this and it will give me a walkthrough about how to configure changes, such as setting that redirect URI back to your local host. And you can even say, make this change for me. You can, it'll show you how to configure the JavaScript app. And it actually walks through the diagram that we sort of looked at in terms of how that sign-in, ID token, access token gets sent back and forth from JavaScript to the Microsoft Identity Platform. And it will walk through the whole process for you. If we look at the examples here, it says that the first thing we're going to do is we're going to embed the msal.js script. And you can reference it really from a CDN that's available from Microsoft. You don't have to install that locally. You can use npm to install MSAL, and then from here we have the MSAL initialization. As we saw on our slide before, this is where it's going to show you the client ID, the authority, and the redirect URI. Additionally, it's going to show you to use that local storage as a cache location. And then it's going to show how you can load that user agent application with the config data that you put together. If you look at this client ID here, I want you to see that it actually maps that client ID in your application. So what's great about this quick start is it actually goes through and uses the real values from your application. So really what you have to do is sort of copy and paste it to make it work. Additionally, it shows you what each of these values are. It explains that that client ID is the application ID of your app registration. It shows about the authority here, and that it's optional, but that typically it is using that login.microsoftonline.com/common. It talks about the redirect, which in this case is going to be a local host value if you're running this in development mode on your local box. And then the cache location is optional, and the store auth state and cookie is optional as well. When we talk about sign-in, you can see here that users are requesting a particular access when they're going to log in. And when you are requesting to log them in, you're going to pass in the kind of access that they want. If they haven't consented to this, they will have to consent to this the first time. For example, user.read for the Microsoft Graph or /scope for custom web APIs. Let's look over at the API permissions here. You can see here that we have those configured permissions. And to access the Microsoft Graph, it has that user.read permissions. So if you're asking the user for consent for user.read permissions, these are the kind of scopes that the user is requesting access for. Here you can see this concept of getting these request tokens of acquire token redirect, acquire token pop-up, and acquire token silent. Next, you can see the ability to request tokens. The first example here shows the ability to acquire that token silently by passing in the request object, which contains the scope the user is asking to access. Down here, you can see if you want to get a user token interactively, you can call acquire token pop-up. So this quick start really walks you through all the steps, and in this example we are using, since it's a single page application, that OAuth 2 implicit flow. Let's go back to the quick start, and this time instead of starting with JavaScript, let's talk about what this can look like if you're using the ASP.NET Core. Just like when we use the Quick Start for the single page application, when we look at this Quick Start using ASP.NET Core, we also get this nice diagram that looks at the flow going back and forth between the web browser and ASP.NET Core and the Microsoft Identity Platform. If we look down here at the example, we can see specifically the code that can get executed inside that startup class within the Microsoft ASP.NET Core authentication middleware. Specifically, take a look at the add authentication method inside the services object. Within here, we're going to call the add Azure AD with various options. The options that we're going to pass in include the authority. In this case, it's version 2.0 of the Microsoft Identity Platform. And we're going to show a list of parameters for token validation. In this case, validate user is set to false to indicate that it can accept sign-ins from any personal or work or school account. Let's circle back to the API permissions here. You can see right here that the user.read permission to the Microsoft Graph is a delegated permission. Remember that this is not impersonation in the sense of it's not the app accessing Microsoft Graph. Really, the app is really, truly accessing Microsoft Graph on behalf of that user. That's why that permission is delegated. Now, if I don't want the user to always have to consent to this manually, it is possible for me to grant admin consent for my tenant. So when I say this, it's actually going to go through and I now can see that this permission has been granted for my tenant. So this is how an admin can go ahead of time and specify that they are granting consent to all the scopes that have been defined for the app. In this last section here, we're going to look at the permissions and consent framework in Microsoft Identity. I already mentioned it before, but we need to really look at understanding the difference between delegated permissions, app permissions, and what's used by apps that run without a signed-in user present, and the concept of effective permissions. So delegated permissions are used by apps that have a signed-in user. These permissions are provided to the application by the user so that the app can do actions on behalf of the user. This doesn't give permissions to the app. Instead, the user is simply allowing the app to act on behalf of the user with the user's permissions. Application permissions are used by the apps that run without a signed-in user present. Now, effective permissions are the permissions that your app will have when making requests to the target resource. It's important to understand the difference between the delegated and application permissions that your app is granted and its effective permissions when making calls to the target resource. For delegated permissions, the effective permissions of your app are the intersection of the delegated permissions the app has been granted and the privileges of the currently signed-in user. In other words, the app can never have more privileges than the signed-in user. Within organization, the privileges of the signed-in user may be determined by policy or by membership in one or more administrative groups. Now, in an OpenID Connector OAuth 2.0 authorization request, an app can request the permissions it needs by using the scope query parameter. For example, when a user signs into an app, the app sends a request like this example here. The scope parameter is a space-separated list of delegated permissions that the app is requesting. Each permission is indicated by appending the permission value to the resource's identifier, which is the app ID, URI. For example, this sample request is requesting permissions to read the user's calendar and send mail as the user. After the user signs in, the Microsoft Identity Platform endpoint checks for matching record of user consent. If the user hasn't consented to any of the requested permissions in the past, nor has an administrator consented to these permissions on behalf of the entire organization, the Microsoft Identity Platform endpoint prompts the user to grant the requested permissions. When the user approves the permission request, consent is recorded and the user doesn't have to consent again on later signs into the application. Often when an organization purchases a license or subscription for an app, the org wants to proactively set up the application for use by all the members of the organization. As part of this process, an admin can consent for the app to act on behalf of any user in the tenant. And if the admin grants consent for the entire tenant, the organization's users won't see a consent page for the application. To request consent for delegated permissions for all users in a tenant, your app can use the admin consent endpoint. As you can see here, it's highlighted in red. In terms of best practices, you're going to only ask for permissions required for the implemented functionality. And that's because a lot of times, since you are implementing this perhaps in an organization beside your own, you don't want this to get flagged by admins saying, there's no way I'm going to implement, that's way too many permissions. If you do the least possible permissions, there's more likelihood that people are going to say, fine, you can read my user profile, rather than, hey, you can update every single file I own, right? So if we look at the permissions here, if an app needs mail.read, don't request mail read write. It's just going to give you greater likelihood that someone is going to consent to those permissions. Additionally, apps should gracefully handle scenarios where the user doesn't grant consent if it's required. So in the case where the app doesn't receive an access token with required permissions, it needs to explain the situation to the user with the options on how to fix it. So your app shouldn't just blow up. You should actually give an answer to the user gracefully and say, hey, if you want this app to work, you need to consent to the permissions. Delegated permissions are used by apps that have a signed-in user present. And for these apps, either the user or an administrator consents to the permissions that the app requests, and the app is delegated permissions to act as the signed-in user when making calls to the target resource. Some delegated permissions can be consented to by non-admin users, but some higher privilege permissions do require administrator consent. For example, a user can grant an app the delegated permissions user read that enables the user of the app to sign in and read the user's profile, and user read basic all that allows the user of the app to read basic profile information about all the users in the organization. Only an administrator can grant the user read all permission that allows the user of the app to read the full profile information of all the users' organization. Now, if the user has not previously granted permission to the app, or an admin hasn't consented on behalf of the user, they're going to be prompted with that consent dialog that we've seen over and over again. Now, when the user selects the accept button, the consent settings are saved and the user won't be prompted again. This is the same user consent we've seen over and over again. There are two ways to request the permissions that drive what is listed in the consent dialog. There's static consent and dynamic consent. And let's look at this. With static consent, the permissions are defined in the app's registration within the Azure AD Admin Center. The static consent approach is how the Microsoft Identity 1.0 authorized endpoint worked. All permissions an application used needed to be defined ahead of time. When the user signed in, they would have to consent to all the possible permissions that were required. This approach also enables administrators to consent on behalf of all the users in the organization. This is sort of an all-in approach, like, hey, this is everything that the app would possibly need, and if you do this approach and the admin approves